Hello everyone, and welcome to the presentation. I would like to thank you all for the invitation, and I would like to first share my screen. Let's see how it's okay. I think this one. Yes, then you have my screen. Share. Today, I would like to. Oh, not this one. Might be this. Yeah, this one. Today, I would like to talk about the future climate scenario in railway asset management decision, TRV's next generation decision support system. Before going to the details of discussion, I would like to share some thoughts from government perspective, like Swedish government perspective in transport administration, and they are working to define and update the existing decision support system in road and railway also to be able to fulfill future demand. And one of the demand for the future is like climate change, and which is missing part of the puzzle in the existing decision support system. As your colleague mentioned, my name is Amir Garmabaki. I'm Associate Professor at Division Operation and Maintenance Engineering, and for the last 7 years, I'm working on climate, part of the climate impact on the transport infrastructure, especially railway. And today I would like to build something based on and introduce some sort of use case regarding application of the data and data mining, which we did during the course of different projects. As you know, every day we are hearing at least in one news in the social media, LinkedIn or newspaper regarding climate change and impact. And this is like last year's scenario in the close to Sundsvall, which different type of vulnerability have been posed to the transport infrastructure. Like we have the derailment, we have a whole part of section in the railway infrastructure flooded by water. Some part of the road completely has been washed out, and also in the middle of the city and urban area, the transportation, like public transport, was not able to function. This is another one. It's like we have an iron ore line, which is extremely strategic for the government and for LKAB also at the same time, and other different connected stakeholder. But we are experiencing that the roof of these snow galleries is collapsing. We have a couple of incidents during last 10 years. And due to like what we are experiencing due to climate change, which is quite unique. For example, in North Sweden, we should expect, for example, 1.5 meter snow by whole winter, that like melting and freezing and melting, freezing, and so forth. And this is a complete circle. But due to extreme climate condition and extreme precipitation, for example, we are experiencing 1 meter in 2 days. And then the load will be huge for the old infrastructure, which is not designed to carry such load. Or in addition to that, railway infrastructure is quite old. It's like more than about 100 years old. And a couple of area, as you can see, is like wrongly designed or designed based on all the specification and design on standards, which in the current scenario, you cannot rely on that. In several areas, railway infrastructure itself as a dam, and one part of infrastructure is flooding, and then you should open the underneath of part to be able to release water from one side to other side. That means that when they did build this infrastructure, for example, they didn't put enough drainage system underneath of this rail infrastructure. There is some things, definitely, every 100 meter or every 500 meter or every 1 kilometer, there is some, but might be misplaced, or might be the dimension is not enough, or might be like poor maintenance is there. The road scenario is not better, is not in a better condition compared to the railway side. This is the last year. If you hear about that news that at 11 o'clock at PM, 11 p.m., one person called police that say that, okay, the E6 is missing, is not there anymore. And the police said, what you mean? I said that the road is not there. And then they investigate that the whole this area is like there is a landslide, huge amount of like earth is like moved towards down, and a lot of cars are working on, like they're driving on the site at that night, or a lot of the connected businesses also is there, if you can see that, but all of them has impacted by such scenarios. But the question is that how to build or how to deal with such scenarios, how we should act like proactively to avoid such disaster which we are facing more frequent compared to the like last 10 years or last 20 years. And this frequency and intensity will increase by the time, since we are releasing a lot of carbon footprint during last 115 years to the atmosphere. In all of the project also, we are working close with the Swedish Hydrological and Meteorological Institute, and we are working with them, and we are asking them to provide a specific type of prediction-related climate connected to, or like connected to rail transport infrastructure, because we have only, our interest is like infrastructure band. And based on that area, they did for like some sort of prediction for us, that for example, but this is almost the similar things for in a general. We will experiencing much more heat in the future, above 25 centigrade, especially in the South Sweden, but the difference, the increment in the temperature will be highest in the north part. As you can see in the image, close to area which I'm sitting in Luleå, you will experiencing about 5 to 6 degrees in the next 20 years, in average annually. It is a huge amount of like changes will occur. And zero crossing means that the temperature in a day and will goes below degree and again come back to the plus degree. With this number of zero crossing will decrease, which has impact definitely on not only road, but also in the railway also. The amount of snow will decrease, and also rain will increase in total in the whole country. And also we have as you may know, that climate change scenario is based on different RCPs. R means representative concentration pathway. In RCP 2.6 means we say that, okay, temperature will not so much increase it, about 1.1, 1.2 degree. And if it goes to RCP 4.5 means the maximum temperature will reach another 2 degree. And RCP 8.5 means you don't do anything, and you don't control your carbon footprint, and then you will increase huge amount of impact in the future, in the next 100 years, and the temperature will increase in average about 5 degrees. Okay, then what we should do then in terms of climate change? And climate change, and to avoid the consequences, the main things which is like we should perform two things together, two concepts. Two types of activity is like climate mitigation and climate adaptation. In climate mitigation, we are talking, okay, how much we can reduce carbon footprint. This is a root cause we should be we should cure the issue from the root, and this carbon is the root, and we should reduce the amount of carbon by different means. For example, renewable energy, energy efficiency building, electrification, batterification, and also waste reduction, and different activities already is there within a Swedish transport infrastructure. They did a lot in this area, but not so much on the right side of the image, climate adaptation, and then emergency management, climate resilience building, preparedness for sea level rise, and all of this needs to be investigated since the oil infrastructure is vulnerable, and we are very, like, we are not big player on producing carbon footprint, but China, India, USA, and advanced countries, they're producing a lot of carbon. At the end, we will suffer. And then the objective is like how to build a resilient, climate resilience transport infrastructure. Resilience means it's like be able to carry the load, and at the same time, if something happens, if breakdown is due to some issue, and easily you can bring it back to the operation. And then different activity should be performed. The main challenge which we during the first part of this journey, we identified that, okay, the data is a like first thing. There is not so much data available. If it's available, the quality of data is quite poor and you cannot trust. This is one challenge. And then how to bring this information and collect this information is another challenge. How to integrate this climate change and climate adaptation in a different TRV department and the development plan in a second challenge. And how to perform risk assessment to be able to capture the amount of risk associated to climate change is also another challenge, because the traffic record, for example, has its own risk assessment portal. They define risk as the probability of failure multiplied consequence, but the consequence cannot be identified by classical way when we are dealing with the environment. Means the new definition of the risk should be defined. And then we have we define some sort of decision support system. We are working with traffic record with this such platform. Different type. We have a data acquisition. We have an impact on the railway infrastructure. We have a different impact from data perspective. Also, as I mentioned, we have a meteorological data, satellite data. We are talking with the expert. We are interview expert. We have a traffic data, and some of them is listed over here. Also, we have expertise on maintenance predictive analytics. And the question is that how to bring and how to use this type of data together. We have an asset degradation prediction, and we have a climate modeling and climate prediction. And then how bring this information and integrate this. This is an important question for us to do it, and we did in different way to answer previous research question, which I highlighted. And then this integration will give us better risk assessment, better alert management system, better safety analysis, and vulnerability analysis. Now, as I mentioned, we have the availability of data is a key for us. And the previous speaker also, Frederick, mentioned that a lot of people didn't completely understood the importance of the data. But the data within a traffic record, especially railway infrastructure, is quite is progressing by the time from 2000 till now we are 2024, and different upgradation and activity have been performed on different databases, and now is like you are able to capture different things, but it definitely is not completed, and the climatic impact is not reflected in the design of this data frame or databases. For example, if the asset is failed and the expert goes to the place, okay, why is failed? They are not able to say that, okay, in detail say that, okay, the flooding was there, and flooding in which direction came, and this information is missing. How much flood was there, and this information is not collecting by traffic braking. But in a way, we have a quite good and structured way of the traffic braking is collecting the data. We have a track geometry measurement data. We have an asset registry data. We have a traffic data. We have a failure reporting system within traffic braking. We have inspection database, and we have other type of infrastructure, data infrastructure that we are using for our research. The same scenario is available in the roadside also, but unfortunately, traffic braking not collecting most of this. But some of them are already started by different stakeholders, private stakeholder that they're collecting or monitoring roadway, or they are installing different type of sensor, or they are using onboard sensor of the cars and collect information and trying to make it a platform to share the data and information to improve the quality of the road infrastructure. The one thing which is important which I would like to highlight regarding the climate and climate change and application of the data is the level of awareness sometimes create a barrier for development. When we are talking with the expert, okay, we want to work climate resilience infrastructure and climate adaptation. They say that we are doing a lot on carbon footprint and so forth. They don't aware so much about climate adaptation activities. They think that what we are doing, climate mitigation, is everything. This awareness is missing part, and we are working at. Although the scenario become quite okay these days, but we was suffering a lot from the beginning. Collecting and integrating various input and the data is another challenge. A lot of data is not available or is quite poorly recorded in the databases, which is not useful. And for example, traffic braking has 877 or 78 weather stations side of the road, but about 80% of them is not active or partially active, or several of them recording wrong measurement. And now traffic braking start to replace the old these weather stations. And we have there is a need for integrating climate change impact with the entire life of cycle of railway asset. Also, we are working on the application of AI and digitalization on climate adaptation railway. And we did different type of project, as you can see, to build the previous framework, as I mentioned, and make one service for traffic braking. The service which is here. For example, traffic braking have different type of services. As you can see in the right side, they have a technical platform, they have a planning services, they have investment services, they have a maintenance services. But in none of them, you cannot find any key parameter related to climate and climate measures and impact of climate. If they ask about, okay, what will happen in the infrastructure considering a specific climate scenario, they don't know actually. And because of that, based on the discussion with traffic, that we say that we can develop this such thing for you, and then this such services as a climate module, and we included climate adaptation tag, climate RCPs, and risk and consequences, and connected to climate change. And this module can collaborate with different services within traffic braking. And then such platform and collaboration and of development of new area which traffic braking also interested to be performed, not only has an impact on education and research, but also create a platform for collaboration, which is important, and also for implementation of the idea within for different stakeholders, including traffic light also we are working. We are working in all the project to and perform barrier and enabler analysis for implementation of innovation also. How to, at the end, this type of innovation can be integrated to their business plan. We are investigating on that. And a couple of use case, for example, I would like to highlight that time is running. Use case one is like, for example, investigation of climate change or climate impact on life cycle cost of railway. And another like investigation of extreme climate impact on reliability of the asset. For example, in the first one, he was able to, as you can see, that we publish in a like transport journal, Transportation Research Part D, and then the simple conclusion that based on different RCP, we was successfully integrate future climate scenario with life cycle cost analysis, and then we came to this conclusion that if you follow, for example, a specific scenario, you will have a 10 to 14% of the life cycle cost will increase if you don't do anything at this stage. Like this is a like optimistic type of like scenario, and the cost will be based on the, for example, this is the one is 2001, and then 30 is to 2030, but the scale up for 30 years until 2019 is like calculated, and then 2019 till 2030 is like predicted. For reliability also something like that. We try to understand how extreme precipitation has an impact on the reliability of the asset, and we mentioned that if we don't like improve on the drainage system underneath of railway infrastructure or this different type of reliability, like as you can plot, we have plotted in this graph that how quick the asset will degrade and will not be able to, the function is like predefined functions. Okay, this one was the last one. Thank you.